which of course it will between now and then. But we probably won't reconvene until the 25th of January. So those of you who don't know, we do this every Friday afternoon at 12:15, but only during the academic year. So that's the time that we can guarantee to come for a weather discussion on Fridays. So we're going to start by just looking at a whole week's worth of red satellite imagery from GOES 16 over the continent of the United States and mostly the adjacent Atlantic waters. But I was away last week at a time in Washington, D.C., and it was a beautiful couple of days there, clear skies as a consequence of this storm departing, and very cold air funneling off the continent. It was pretty cold those days as well. And then there was another event along the East Coast in the mid part of the week. There was a giant event up over maritime Canada, both Wednesday and Thursday. And that's probably where we are now in this movie. I'm not sure if I'm right about that. I'm going to force right now. Where's the date? Oh, right there. Okay.
Yeah, here it comes. Off the East Coast.
Yeah, so it's the next event. Here it comes. Yeah, this is a beautiful event that really got itself wrapped up nicely. Although it's smaller in scale in terms of the circulation and the clouds would suggest. But a really nice storm. It's been a stormy month of November and now into early December over Newfoundland, parts of Labrador. They've had places, Goose Bay has had some record amount of snow this year so far. Goose Bay, Labrador, and places on Newfoundland have had over 100 inches of snow or something already. They get a lot of snow, don't get me wrong. I mean, their season is snowy, but not usually this much this early. So it's been one after another, and it's been cold over North America. And I'll show you some evidence for that in just a second, but not right now. Aside from the storms on the coast, especially the East Coast, it's been a fairly tranquil week across the central United States. I think you'll see some reason for that when we look at the upper level charts. It's been sort of a broad upper trough sitting over the eastern 2/3, arguably even more than that of the country for much of this week, maybe especially the early part of the week, preserving, all the interesting flow and confluence and various other things associated with it is on the southern periphery of that broad upper trough. And a consequence, we've had a pretty nice week here. It's been cold and only a few snowflakes floating around, but nothing of any substantial magnitude. Although the cold has continued to be somewhat notable. So can we go to the West Coast and take a look at the week in the West Coast as well? So this is really interesting. One thing I'll say, just as you watch it, again, it's a 1 week animation. Watch how stationary the clouds, at least is shown in the infrared, are at about 160 degrees or so west. They just sit there for a large part of the week. But then there are a series of swirlies. Here comes one at the southern end of the Aleutian chain. It's a pretty intense storm. There'll be one that digs. Maybe we already missed it early in the week. I thought coming now. It's going to dig south in a northwesterly flow. There's some of the fire-destroying storms that are finally inundating California, parts of the state anyway. This went to, 5-minute imagery there went to peak for a while?
There was a 4-hour period on the 4th where they did 5-minute full disk imagery. Yeah, so slow down.
This is a really nice view because you see simultaneously the ITCZ south of Hawaii, which is at about 24 or 25 degrees north. And then you see the whole Northeast Pacific Basin, which has been active. Here's the one that I was talking about. You can see that it's right near the end. So wait for that to come out. There's cold air outflow out over the Bering Sea and then south of the Aleutians that spawns the latest cyclone in that series. But look at how there's so many convective, organized convective clusters that have kind of crashed onto the northwest coast. Some of them are just bona fide extratropical cyclones. And then occasionally you get these places where the convection gets self-organized and sometimes spawns a cloud shield. There's a nice convective cluster in there. And we'll see one last one as we're getting close to the end of this week. It'll come, look at that ITCZ, isn't that great? They caught it right at a time with a big cluster there. We'll see this come straight down out of the eastern part of the Bering Sea.
Is that are we looking at the Central Pacific El Nino right there, that cloud cluster in the lower middle?
This one here?
Yeah, that kind of area there,
I don't know, I didn't notice, is that persistent in one spot?
Well, it's all part of the El Nino. I mean, the whole ITCZ is extremely active right now. The subtropical jets are just overwhelming everything at this point.
Well, yeah, but it wanes. I mean, the eastern part of this wanes during this image, and it grows in the west, so it's not continuously active in one spot, even over this week. So look at here, the eastern part of it is active, and the western part is not. early in the week, and then it shifts back the other way, which is interesting. So there's a lot of variability along the ITCZ, even in broad longitudinal swaths.
But there's a lot of strength in it.
Yeah, that's
Compared to a non-alien.
it'd be interesting. It's probably a way to do this, right? To just calculate the, I guess you could do it in a number of ways, but one would be the area of infrared imagery that comes back in a certain temperature range over the length of the season. Yeah. Just integrate the OLR. But so you can see that's actually really interesting that it transfers back and forth across here. Here comes the storm in the northwesterly flow. Isn't that nice? Right at the end. Can you go back just to that? I don't want to have people watch the whole thing again. Yeah, so here it comes right here at the end of the Aleutian chain. It's kind of getting itself organized. That's the next biggest swirl in the Northeast Pacific Basin, and it's coming right on the heels of one that's kind of crashed in. I don't think it's rained very heavily here, but it's rained persistently in the Northwest over the last week. But I don't think they've had anything particularly intense. Sometimes in mid to late November, you can get really intense rain events in the Pacific Northwest, and they're not really, you don't like to be there when that happens. It's landslides, various other things. The bridges can get inundated, bad nose. It's not pleasant if it's really extreme. It doesn't seem like it is this year, at least not this November. Okay, so now let's go to a more close-up in time view. Let's take a look. Oh, what is this? First, we got to see this. This is today, right?
This is yesterday.
Yesterday, okay.
There was something interesting that I noticed in the cloud shield over northern Wisconsin yesterday. You can imagine, you're driving down the road in the summer and you see kind of heat shimmering on it. There was a similar sort of effect going on in the clouds up here. I don't know what that is. Starting right about there. What's going on here? Right near the end of the day. There's like low clouds over the northeast part of the state, and then I don't know if those are waves coming off of what's going on down here.
Yeah,
I just thought it was weird.
sort of westerly flow. The jet flow is to the south, but there's still broad westerly flow. I wonder if there's just some sort of waves rippling off the Baraboo Hills or something like that. But one other thing you can see that's really dramatic, of course, is the cold air funneling over the open Lake Superior, the open Lake Michigan, and these beautiful stratocumulus lines that come out of there. And then, of course, the near-shore divergence zone, because the frictional retardation of the wind is so much greater over land than over the water that you have divergence near the surface upon it coming across the boundary. And so you have a clear spot, but there's a lot of sea smoke and then stratus clouds pouring across the upper peninsula of Michigan. I don't know if they had any snow yesterday. I can't believe they didn't have local snow showers, at least probably some accumulation as well.
For those who are interested in lake effect snow, there is a Great Lakes sector available on the 16 page now also. So that's, let's see.
Right there.
Yeah. That's today.
That's nice, isn't it? And here's a strip of snow from the post-Thanksgiving event, looks like.
Yeah.
It just hangs in there because it's been so cold. I mean, it's been sunny, but it's been cold. So this snow is taking a long time to get rid of it. I landed in Chicago, I guess it was Monday, and they still had, clumps of snow, on the runways or on the sides of the runways.
What's normal temperature for this time of year?
Right here, it's like 39 for a high or something like that.
Oh, it's that high?
37, maybe it's a little bit lower than 39, but it's in the mid to high 30s, I think, right now. Is that right? Here's approximately December 1st. Oh, mid 30s, like 35. Yeah. So, can we take a look now at the Eastern United States visible satellite image for the current time? We've seen a lot of here's that big storm in the North Atlantic in the visible imagery. It's pretty nice. Too bad it gets caught by the terminator. That's unfortunate. Here's our snow band from the prior storm. Look at that. Northern Missouri has snow before us. There's something really cosmically wrong with that, in my opinion. I'm very upset about it. There's some snow in Iowa and, of course, all the way across the state of Nebraska. And in fact, we don't see any particular chance for snow until a week from today. We might get some then, but who knows, a week out. It's disappointing. So you can see some things on the satellite right away that might catch your attention. One is what appears to be a flow straight across the southern part of the Gulf of California, across Mexico, and then into the southwest United States. That's all from the southeast. and then there's flow along the California coast from the north and northwest, indicative of the presence of an upper trough off the Baja California. So we'll take a look at that at 500 millibars in a minute. And as a consequence of its presence, there's this flow of kind of probably a little bit more intense tropical type air coming across them. It has to get across Mexico, but nonetheless, it gets itself into the southern plain states. And we'll see that that circumstance, coupled with the continued northerly flow and northwesterly flow over us, produces a confluence zone across the southeast U.S. And that's probably the mechanism that drives the continued production of the precipitate clouds here. And we'll see in a minute that's precipitating in the radar. So that's pretty nice. Meanwhile, the cold air that comes down in that northwesterly flow is not subject to much of that dynamical forcing for ascent. And you can see it's widespread clearing, some high clouds and maybe some low-level fog over snow and whatnot. But broadly speaking, the northern half of the United States is pretty clear, all the way almost to the coast, where it's somewhat imperiled by the approach of that storm off the Pacific coast that we saw. There's always interesting cloud features along any of the adjacent waters. Who knows why it's persistently clear in this one spot off the west coast of Florida today? It's just hard to understand that at a glance. And certainly, perhaps, I'll just give you my own opinion, not particularly worthy of further diagnosis in this form. But it is amazingly interesting that it happens at times. Look at that. Why is there such a sharp line along which these presumably stratocumulus, or maybe even deeper than that cumulus, develop?
It's got to be water temperature, doesn't it?
Don't you think that must be part of it?
That's the shelf area there.
Yeah, but is it that much colder? I guess so.
Just good with Sims or SSAC SST map.
I don't know if we do it or not.
No, it's just
Go to the top one. I think we scroll down to the regional view. You have to, if you click,
Right in here.
when you're hovering over it, you have to go into the, so now go into, I think when's in analysis.
Basin. I don't know. But it's interesting, isn't it? And it won't be the last time, and it'll be in a different spot on another time. So there's all these weird things that you can find on the satellite imagery. People have heard me say this in 452 all fall. You know, sometimes someone will say, I'll agree with them to an extent. Today, the weather is boring. It's never that boring. I mean, you can always find something that you can't explain, and usually within 5 minutes. And if you can't, you're really smart. So,
is it leftover from the night before, like offshore?
Yeah, I don't know. I mean, that's possible, right? That is possible. But it does look like there's something generating along that edge when you get this close up. And I didn't notice that until we saw this close up. That is just really weird. So I don't get it. But it isn't the first time I've seen it. Maybe someone's conducting oil on the water experiments to inhibit evaporation or something. They actually thought this was a big deal. Like you could steer hurricanes by spreading oil, vegetable oil, over the ocean. I bet there's people who still think so, but I have a feeling that the large-scale forces that drive those things have a lot more to say than vegetable oil. But anyway, let's take a look at the 500 milliwatt chart. Radar first. What fraction of the clouds are precipitated? Yeah, that's better. So we're going to see with the cold northwesterly flow, especially in the eastern part of the United States, a little bit of lake effect snow off Lake Erie and Lake Ontario. Looked like it was going to be worse in the Tug Hill Plateau area of New York than I think it ended up being. And now it's kind of directed more towards and south of Albany. But here's the interesting and broad scale region of precipitation across the southeast United States. And you can see that the radar doesn't get too far into the northern states of Mexico, but one gets the impression that this is all flowing poleward. And that's not surprising, and you'll see why in just a minute. But it's kind of not particularly well organized, but certainly it's clear that there's something going on along a line like that, and I think we can make a diagnosis of that, which we'll try to do now. So let's.
That's almost right over the El Nino anomaly. When you have El Nino, there's an anomaly.
Oh, is that right?
It stretches right across that band.
Is that right?
So it's
And in the next 2 days, the Storm Prediction Center has a marginal risk along the Texas coast today, and then a marginal risk moves eastward with the upper trough, which is changing its shape and its dynamics as it goes. That's interesting. Yeah. So this is the place where it rains when you have an El Nino.
Pretty good risk of heavy rain in Texas.
Is there?
In fact, all 4 of the GOES mesoscale sectors are over that area
Oh, is that
right
right?
now, yeah, which is bizarre.
Yeah, that's going to be in the discussion of the forecast, we'll be talking about the emergence of a modest cyclone.
Yeah.
From the Gulf.
Okay, so let's go to the 500 millibar super Peats. So here's our 12Z analysis from this morning. So I'm not going to show a movie of these. They're available. You can see what I mean. This bowl-shaped upper trough has, say that's the centroid of it, the axis of it. That's moved ever so slightly across to the east over the course of the last few days. But the basic structure of this upper trough has not really changed much. It's kind of broad, and imagine it displaced a little bit to the west earlier in the week. That puts us in weak, sometimes weak flow at 500 millibars, but usually with a jet flow to the extent that exists at 500 to our south and to our west. And now it's kind of right over us at 500 millibars. At 300, I think it's a little bit displaced from that. But you can see this broad confluence over the central part of the United States. And so on the warm side of that confluence region, one might expect that there's at least no discouragement for ascent going on across the southeast based on what's happening at 500 millibars.
I should mention that this is again almost a perfect El Nino pattern. And the split flow like this from the west coast is what's typical of El Nino. You get a southern branch with a subtropical jet down there, and then you get the northern branch, which comes onshore up very far north, and then we get these little ripples all winter long. It gets a little bit cold, but not that cold.
Yeah, and a little bit of
And,
snow.
and most moisture never makes it in here,
Yeah.
or only if we're very lucky that the moisture gets.
Yeah. One of the elements in that picture that seems unusual to me is this trough right here over Baja California. These geopotential heights are on the order of 200 meters lower than normal for this time of year. I looked at the NCEP plotting page for that. They don't have it, at least I wasn't able to find the standardized anomalies, but the further south you go, the more anomalous a 200-meter height perturbation is. So I bet you these are on the order of 2 or 3 standard deviations, maybe more than that. And there's also evidence in the analysis as it's constructed of an upper front on the back, on the western side of that feature.
Yeah.
That's really interesting. So this is a feature of considerable, let's say it's related to polar type disturbances in the mid-latitudes in the wintertime. And here it is well south of the United States. And it's having an influence via production of southwesterly flow on the precipitation in the region that usually gets it at this time of year in an El Nino. So that's really interesting. If you throw an El Nino picture over the North American continent and an unusual and perhaps foreign visitor from high latitudes into that flow, things are pretty different.
So a couple questions. One, or comment and a question. So Greg's comment about split flow, that's kind of interesting. It's been quite a while in Weather Watch that we've even used that term. And I wonder if we just haven't had patterns of this sort as prominent as what we're seeing today.
Yeah, I don't know. That's right. It's just that it hasn't been so obvious.
Right.
Perhaps.
And related to the split flow, I mean, this, at least back in the 20 years ago, there used to be a significant forecast challenge with these split flows because you'd have disturbances in the northwesterly flow that have some potency upper troughs that originate at very high latitudes. And something in the subtropical jet that emerges in that southwesterly flow over Mexico, there's often this question of the issue of the phasing or the superposition of these anomalies to result in a significant storm somewhere over the central or eastern United States.
Yeah.
And it just strikes me when Greg used that term, we haven't thought about those sorts of issues in quite a while, I think, in any Weather Watch.
That's right.
Probably 2 or 3 years maybe. So this is an unusual pattern. And then is the origin of that, I haven't followed it carefully, was that originally a low latitude trough or did it actually have its origins?
This one here?
Yeah.
I don't know. We could look at the movie, but it only carries us this far west, so I don't know if it's worth it, but I don't know the answer to that. That's definitely a question of interest.
Because we talked about significant low latitude, high amplitude disturbance at low latitude last week's Weather Watch.
Right.
And just for the southern stream, the subtropical jet being kind of active.
If you look at the jet streams, that's all subtropical jet. There's the only real significant polar jet is off to the west or east rather.
Right here.
Yeah.
Yeah.
Well, that's not even significant. The subtropical jet there's a jet up there, but it's not much.
But the thing that's interesting about that map,
See?
yeah, not particularly strong. Yeah, what's interesting about that map is this jet structure right here. It has that strong, very obvious upper frontal signature at 500 millibars. I wonder where that came from, and I don't know the answer. It's possible if we go back, yeah, see that right there? That's 10 degrees of temperature contrast right there at 500 millibars. And the 300 millibar map might suggest that it had some connection to a flow that's broadly from the northwest over the date line.
I think that's the subtropical jet pushed up, and then I think the circulation around the subtropical jet caught on to the baroclinicity at the surface, at the low levels that was brought down by previous polar disturbances, and I think it's reorganized it. So I think it's a hybrid system of.
Okay. Here's something I've always wondered about. No one talks about this. There's absolutely no prohibition about the subtropical jet generating a more substantial upper baroclinic zone than normal. And it has to be under the right circumstances, which
Right.
may have
That's
existed.
right.
I think there is, sorry. This baroclinicity that you're showing.
Yeah.
I mean, it is prohibited. The further south you go, it's going to be tougher to maintain that because it's
Yeah.
going to result in something that's very unbalanced, right? You don't see fronts in the tropics typically because you can't maintain a very tight temperature rating because the Rossby deformation radius is so huge. So it must be something to do uniquely with the circulation in that trough, significant vorticity, potential vorticity that's helping to maintain that structure. Because the further south it goes, it's going to be difficult to maintain a big front.
But if
Yeah.
you look at 200 millibars, Pete, it's the, see that jet? I mean, that's a huge subtropical jet there.
Oh, yeah.
And you look at the precipitation over the south there, it's right in the entrance region where it should be on that
And on the warm
subtropical.
side of it. So.
Huh?
And on the south side.
On the south side, but it's the entrance region of that jet.
Yeah.
So I think that jet this is what I've been saying all along, as these subtropical jets from the El Nino come into the continent, their circulation comes to the ground because of the reasons you said. They can't do it in the tropics. They're just shallow up high. But once they get north of about 30 degrees latitude, their circulation comes right to the ground and corrals the baroclinicity, and it's creating vertical motion in there, which is driving that precipitation.
That's reasonable. That's a reasonable.
And you can see that if you look back at the satellite, that's coming right off the ITCZ.
Yeah, when it was in the late part of our satellite movie, the
Yeah.
ITCZ was weak in the western part of the domain. It was strengthening in the east, weak in the east and strengthening in the west. Right, so this is the late part of the movie, so it's kind of gotten a little more active in the central Pacific and less active.
But I think earlier on, it was more active over there. Before.
Yeah, it was earlier in the week. That's a big distance, though. That makes me nervous to say that this is directly connected.
Now, these plumes can go all the way to the pole.
I know, but that's a huge distance, when I don't see any particular evidence for that connection right there then. Okay, so anyway,
Look at that.
yeah, there you go, there's clear evidence of some connection, right? That's earlier in the week.
That's it.
You sure that's it?
But 3 days ago, 2 days ago.
Yeah.
Where are we now? Is that about the same time as now?
So
Yeah.
Yeah, there's the upper trough. Okay, so there's the upper trough coming. You can see the flow is turning, so. Yeah, so it may be shot out earlier and then just been dragged further to the north by the trough that's kind of made its way along the coast. This even gives us an indication that that thing maybe did emerge from higher latitude, right?
I think the lower portion did. I think it's tapped into that baroclinicity down low, and now it's become a hybrid jet.
Yeah, but I mean, where the upper trough come from, the anomalous upper trough
Oh,
in Baja California, that did slide along the coast. So that's got an extra tropical origin. So it's a very interesting complex that's poised to start to wreak havoc in the central and southern United States, beginning now. It's already doing so now.
It's a good case study of an El Nino pattern. This is exactly what El Nino is supposed to do. That's what it's doing.
Okay, let's, I'm almost done. I only have a couple things I want to say. I guess we're done here. Let's take a look at a couple of the things I had on the bottom of the page, Pete. I don't know where they've gone. Oh, you just hit it? Let's first look at,
It's going to be listed on here.
oh, yeah, okay. Let's do this one first. So this is my -5, 850 area. And we just crossed into, I'm going to start probably next semester showing you just December, January, February, but this is the lead up, September, October, November. One thing I'll say right away, the last time we were above the average, which is in blue, in this season was on September 11th. So we've just, and then the first time since then was yesterday, the 6th of December. So we've had 85 straight days with the 850 millibar cold pool extent lower than the long-term average for the hemisphere. It's the 10th warmest September, October, November on record in the 70 years of the NSEP reanalysis data. Among the top 10, this one being the 10th, so I'll say, I guess, among the top 9, what happens in those 9 years after September, October, November is quite interesting, but not at all definitive. 3 out of those 9 years have a tremendous sink from being relatively warm to exceptionally cold. Actually, they end up, some of them, 45th warmest and 54th warmest by the time it's all over, December, January, and February. So a warm fall does not guarantee a warm December, January, February. However, of the remaining 6, one of them was 6th warmest September, October, November, remained 6th warmest December, January, February. And the other 4, I guess there's 5 maybe remaining, they all stay within about the top 10 or 12. So most of the time, a warm fall in that sort of range, top 10, gives one the impression that the winter is going to also be warm in the top 10 to 15 range, but not always. So, and I don't know enough about statistics to have a better sense of it than that. I just wanted to report that to you. So it's been 85 days since we had a hemispheric day with the cold pool extent greater than average, and it's barely greater than average right now. So this has been an interesting fall. And let's take a look at the September, October, November average departure at, I think this is it. This is the NSEP plotting page. So this is the departure from 850 millibar air temperature, not just -5, but air temperature everywhere over the hemisphere for 850 for that same period of time. Unusually warm. Turns out it was ridgy here also over the Bering Sea, north slope of Alaska into the southwest. I don't know if you call it southwest, I guess the western part of the Arctic Basin. Cold over central Canada and, of course, spilling into the central United States. And everywhere where there's no shading, it's 0 or colder than normal. And so the really unusual spots for temperature anomalies were really warm right at the land bridge area. And then downstream of that, presumably there's a ridge here, and then northerly flow has consistently inundated Canada and the northern United States with cold air. So we were really in a record warm hemisphere period, the only cold spot besides the Canary Islands and the west coast of North Africa. So that's interesting.
Hey, John,
Yeah.
have you looked at this for the very top 9, like with the patterns of flares? This
No.
looks a lot like 2014
Good idea.
to me.
Does it? Is this what happened in the fall of 2014?
No, I'm in the winter, like January, February.
Oh,
remember
yeah.
being Looking like that, where it was very cold over North America.
No,
Alaska.
I didn't. You had a good suggestion. It's easy to do. I know what years they are. I can just look at the same exact plot for those years from the same days. I haven't done that.
You can actually, I guess there are tools on that site that you can select the years or the periods you want to do the anomalies. You can take all of them, the periods where you have the years that you have the warm periods,
Yeah.
and do an anomaly map like that.
Oh, yeah, I've done that in prior research, but not for this. But I think it's good to do both, to look at individual years and then to kind of throw them all together and figure that out. But anyway, that's the story. Nobody who lives here and doesn't pay attention to the weather around the hemisphere would think they had a warm fall. But it was the 10th warmest fall on record in the northern hemisphere, 70-year record, but not so here, as everybody well knows. So that's interesting. And Greg said something interesting about this the other day, saying, hey, is this why, think about this in an extreme case over, geologic time, is this why this is a spot where the ice was able to form under other different circumstances? Is this signal something that can sometimes be resonant with the geography? It might be. So that's kind of interesting. But I don't think there's any ice on the Canary Islands.
One last thought about maybe why we're going back to normal in terms of the aerial extent. Thinking about your paper, there was a big cold surge that kind of came off of Siberia and had been pinched south for 10 days ago or something, which kind of in line with your paper that seems to be the area that kind of governs the hemispheric average.
Yeah, the one spot on the globe that that was actually December, January, February only, that analysis. But nonetheless, that spot is interesting. That is northeast China and the central coast of China. The correlation between when it's cold in like Beijing and whether or not there's an unusually large area is very high. And it's the only place in in the whole northern hemisphere where that's true. So there's something maybe about the East Asian winter monsoon that gets revved up that controls some of this.
One reason why we're not officially in an El Nino is the Southern Oscillation Index is still, was it too negative? And what's happened in the past day or two is you suddenly are starting to see this, the chi maximum, the chi minimum, the upward motion maximum over the West Pacific and Southern Asia is starting to shift into the Pacific.
Where does it have to
Last few days.
shift? Does it shift into the Central Pacific?
It's shifting into the less of being as far, it's shifting toward the Central Pacific. As a matter of fact, the sinking motion of the Walker circulations pretty much moved on the coast of North America.
Okay.
Or South America. It's moved over. And so the Walker circulation is definitely shifting, which might be related to the Siberia where there's high.
Okay.
I mean, it might be, the whole patterns might be shifting to a more El Nino supportive pattern.
Interesting. I have not kept track, I have in prior years, kept track of the modulation of Siberian high. I think it got off to a slow start. October was really warm in Siberia, Mongolia, but that turned around in November. That's not been the case. So they end up with kind of an average season, September through November. So that's all I have. So Michael, do you have some stuff about the forecast?
First, let's go to the expert assessment page to look at the upcoming hazards for the next week or so. Hazards outlook. And so a couple of things that we can see are the possibility of some significant snow that's forecasted over the central Appalachians from eastern Tennessee through southwestern Virginia. Possibility of some freezing precipitation in this zone between that and then broad area of above normal precipitation forecasted for the southeastern United States. We'll see all of these hazards in this region of the United States are going to be associated with this upper trough that we've been describing that's marked off in the southwestern part of the United States. Dry conditions continue throughout. You can hover over this for just a second with the cursor, please, or click on it, maybe. It should show it. Just the severe drought conditions, not just dry, but severe drought conditions continuing over parts of Oregon into the central and southern Rockies. So drought conditions there, and then we click on just the far west coast, and they're about to get another rain event there, heavy rain coming in the next couple of days, with what may be sort of one of these so-called atmospheric river type events. It's also hints of it in the satellite imagery. And then finally, just away from the coast at high elevation, the potential for some heavy snow. And lastly, flooding likely in the next couple of days, with that persistent south side of the confluent flow with a thermal gradient generating some significant acid. So what I'd like to do is go to the tropical tidbits page and look at the forecast models. And first, just take a look. We can step through, I think, just with the cursors to look at the evolution of the cyclone that's expected to develop in central Texas later this afternoon and this evening. And we'll see it's going to track along the Gulf Coast into just off the mid-Atlantic or the southeast coast of the United States. On the north side, we're going to see significant snowfall. I think it's an interesting evolution because it's, I think, primarily driven by the upper trough that's off the west coast. But I think these two weather systems, the surface cyclone and the upper trough, become decoupled at some point once it gets over Texas, and you just have a surface thermal wave that propagates eastward without much upper tropospheric support. And then eventually we get an upper trough that's back over central Canada that comes along and sort of picks up the western edge of this later this weekend into early next week with a pretty significant cyclone that's offshore. So if we just step forward in time, we can see the evolution of this broad area, heavy area precipitation. We're at by 18th of the night. We're looking at 12 days. Sorry, which forecast? Right. Okay, 60. That's going to be midnight. And we go forward. You can see level pressures aren't really that significant. This is 1,010, 1,012. It's not really developing. The north edge of this, we just stopped. This is Saturday evening at 7 p.m. 0Z. See the north edge of it, a little bit of ice, a little bit of snow as you get into just south, get into western North Carolina. But this cyclone is not particularly intense. It's been around 1,010, 1,012 as it moves eastward. Notice, if you look carefully, the minimum sea level pressure is pretty close to the location of this lower tropospheric thickness ridge. Right, the thickness ridge is going to be characterized by a lower tropospheric, at least from 1,500 millibars, thermal anomaly. So this is just a cyclone that's right along the peak of this, and that would suggest there's not much in the way of any disturbance in the upper atmosphere that's helping to move this along or intensify it. So this is, we'll look at another level, 850 millibars shortly. We'll see this is sort of like a surface thermal wave that's just propagating, or near surface thermal wave that's just propagating.
Well, maybe this is just the subtropical jet driving upward motion in that region, and there's no lower part to it.
Well, I think there's a lower part. There's not much at upper levels, and we'll see that. I mean, this is something that would be a nice sort of case study in either 452 or 651 type of graphs where you can break it, the atmosphere into parts, and you can probably see there's not much of a contribution at this level at the surface to anything from the upper troposphere. I mean, it's largely driven by the surface, or the surface as opposed to the upper troposphere. And the reason again for that is that the surface thermal ridge is almost perfectly coincident with the minimum in sea level pressure, the minimum in geopotential heights. If this were a cyclone that was interacting with an upper wave, you would see the minimum sea level pressure back here, just to the west of the thermal ridge axis, which would indicate you have two pieces that are helping you.
So it's almost like an occluded cyclone from the beginning.
So
It's almost
like
vertically
that.
stacked, is what you're
It's vertically stacked in the lower troposphere, but without anything going on really in the upper troposphere, which I think is kind of an interesting structure. If you keep stepping forward, you can see this is right in fact, even on the eastern side of this, that might be because of late heat release generating EV in the lower troposphere. But by the time this gets to just east of Jacksonville or northeast of Jacksonville and south of Savannah and just east of Savannah, you can see the precipitation shield has now gotten to a region where the cold air damming, see the ridge that's extending along the Appalachians. This cold air is, the hydrostatic reflection of the cold air here indicates this little sort of V-shaped region right here, just on the east side of the Appalachians. This is where you're going to be getting some fairly significant snowfall. I think the look at the total accumulated forecast for there, but probably 6 to 12 inches or so in these parts of the eastern United States.
I think that's going to be a tough forecast because it's not that cold at 850. And it's going to probably snow for sure in Asheville and Charlotte, but I don't know about Raleigh. And it's on the map. It says Raleigh's getting big snow.
Right.
That's a close call.
Right. We'll look at this. We'll look at the accumulated forecast because it's really interesting. See this broad area of snow, but in terms of accumulating snow, it's going to be much narrower and focused with elevation.
Oh, yeah.
I think. So that's. I think you're absolutely right. That the temperatures going to be critical for this. We get quick ahead. This is Sunday morning. Now, finally begin to see some deepening here, which is of interest. But you can see that in the ice, this is liquid. This is freezing precipitation, sleet, and snow here. So this is going to be probably in the news. They'll be talking about a southern snowstorm or ice storm and how unusual it is, but these things happen, and perhaps in El Nino years isn't too uncommon. But the forecast has been really a challenge for folks in the eastern United States because some of the forecast models have actually brought the leading edge of this precipitation all the way up to the nation's capital with the possibility of some snowfall there. But more recent models and the trend of them have moved the precip, confining it mostly to southern parts of Virginia into the Carolinas. That's not a bad looking cyclone.
Is the 2 millibar contour interval becoming the standard? I mean, these guys in Pivotal both use 2 millibars when it's traditionally been 4.
Right.
I think it's just because of the smaller scale features that are resolved that are easier to see waves and other things.
I think that maybe. I think it's flashier.
Yeah, it's drama. I think it's the way to capture the broadcast audience that you get on the Weather Channel and making these things all look more intense.
It's the little drop in at 5 minutes into the news where they say we could see snow on Friday, and then they come in the forecast and they're like, might be a dusting.
Right.
Okay. So the issue here is just that typically when you do an map analysis of this sort, these surface pressure, the traditional contour interval is 4 millibars, but it's possible that maybe people are looking at as the resolution of the models can resolve smaller scale features. You want to be able to depict them, so that may be fair, but I'm old school. I prefer the.
There's a couple of wavelength features that are showing up right there. I don't know if those have any tie to reality, but
We can go a couple more clicks forward just to see this as it exits the coast, 1004. And it's also shifted a little bit further to the west, which may indicate that there is beginning relative to the thermal ridge that there might be some
sliding to the east again.
What's that?
It's sliding to the east again.
Yeah.
That's
It's not
split flow.
turning around for break. So we're gonna look at some other levels, but I just want to give you a sense of the evolution that you can actually see this sort of splitting off, heading to the east, so this hangs back. Okay, and the snow's pretty much over there until this next cyclone. Just go, if we can quick forward rapidly, you can just see, watch what happens there. Then another cyclone spins up there.
Mhm.
And if you go back a second, you can see that at least in terms of the thickness field, here's this feature here, which we'll see at upper levels is also associated with a potent or becoming more potent upper trough that eventually interacts with it. You step forward in time again, cyclone seems like it's all gone. You have this trough approaching, and then you begin to see another event just beginning to develop. It's even more intense than the initial. Okay, so to get a couple different perspectives of this, if we could scroll up just a little bit on this map. And up, yeah, this way. And what I'd like to do first, let's look at some of the origins of the precipitation that we saw that were there, and some of the processes that might be associated with it. This 850 millibar temperature advection, which is the shaded regions. We'll see frontogenesis will be in these purple contours, and then we have the ice of the wind at 850 millibars. So here's where the 850 surface is sort of outcropped into the mountains, so we can't really see anything here with the intersection of the mountains below the surface. But what's really interesting as we step forward from this morning, let's get to 18Z. So you can see fairly quickly as this upper trough is progressing eastward, we'll look at where that is. We can see that there is frontogenesis that really begins to develop and get enhanced from central Texas toward Louisiana. If you go forward and click, you can see it's along that. And with these frontogenic circulations in the lower troposphere, we might expect to see, separate from the larger scale flow field, ascent on this warm side, descent on the cooler side of this is presumably going to slope upward, so there's frontogenesis not at this level further up. So this is going to be the focus for some of the precipitation that we see across the southeastern United States.
So what's causing that frontogenesis?
I think part of it is the circulation of the upper trough impacting the warm side of this baroclinic zone. You already have a baroclinic zone here. It's about the wind interacting with it. I think one of the features that's happening is that you get stronger winds, southerly winds on the warm side of the surface because the stratification is weaker here than it is here. So the upper trough can penetrate down more.
See, I would say this is a prime example of the subtropical jet building down. And it's,
Okay,
what's happening is subtropical jet's creating a circulation, which is creating frontogenesis down low, and that's bringing the winds down.
okay. I'm saying that at least initially the upper trough is something in the upper troposphere is responsible for this. I agree with that.
Yeah. So this is how an El Nino circulation coming in with a subtropical jet is creating a polar jet or creating a polar jet signature at the lower levels associated.
Could very well be the case, but let's watch as we go forward in time with this. So we have the frontogenesis here, and it's going to continue extending eastward. Kind of this. Look at this region here with strong warm advection into where the thermal ridge is developing. Notice that the circulation here, at least where we see the greatest amplitude of the thermal ridge, is almost precisely centered on this, or nearly centered on the location of this thermal ridge. I think at this point, there's still some left over from the upper trough. Let's go forward another time. Into the time period. This is, I want to make sure,
36 hours.
this is
0Z Saturday night.
Jersey. Now I was looking at the times and winds because this is a little different than I was anticipating. You can see here's where the thermal ridge is. The surface the circulation 850 millibars is actually moving to the west of this. So that's a little bit different than what we were seeing just looking at the 50s. But you can see again this band of enhanced frontogenesis here, and that's going to be the focus for some of that initial precipitation. Here's cold advection on the west side of this. Slightly frontogenic over here in southeastern Louisiana. Let's keep stepping forward in time with this. Here, remember that precipitation that we saw. We can do another click and just go up to 700 millibars to see if that frontogenesis extends further to the north. Click on, this. Oh, 700 millibars, sorry. 700. Then you can see that. Yeah, that band of frontogenesis extends from the intense baroclinicity at 850 millibars upward to 700 millibars, so it's sloping upward. And so that sort of marks the leading edge of where the snowfall precipitation is going to be. You can also see at this level at 700 millibars a nice region of diffluence, the broad axis of dilatation stretching out here. And that's going to really, where this sets up, where that axis sets up is really going to mark the northern edge of where that precipitation is going to go. So how well the models forecast this is going to be critical for how far north this precipitation extends.
Noticed on the GFS 700 vertical motion panels, there's a really sharp and narrow downdraft on the back side of this confluence region.
Right. You'll be
It's
right.
not always the case, but this is really dramatic, and it's on the whole length of the frontogenetic band on the cold side of it.
Right. So this is kind of a classic setup for the types of circulations you guys talk about before.
Yeah.
I imagine. Okay. What about just look at a slightly different perspective. Let's look at 300K relative humidity and pressure. So now looking at 300 Kelvin isentropic surface. Relative humidity is shaded here in percent. We have the isobars also on this map. And remember, the isobars on a constant theta map are like isotherms because theta is constant, and looking at an isobar, that's the proportional to temperature. So here, what we're looking at is on this map, and this is at 12Z Sunday when that precipitation's moving northward. On this isentropic surface, we can see flow from the lower pressures toward higher pressures. Okay. If these isotherms weren't moving, it's kind of related to the recent 310 exam question, but if these isotherms weren't moving in time, we could easily use this map to diagnose vertical motion, right? You have flow going from higher pressure toward lower pressure, that's going to be associated with S. And notice as this flow moves northward, again, it is also on the south side of this bifluent, or excuse me, it's confluent here at this level, or on this particular surface. You have a lot of dry air to the north, you have this moist air from the south, this dry air descending, this moist air ascending, and it's create a very sharp cutoff line in the precipitation as well as in the vertical motion. So this is another depiction of why we're going to expect to see a very sharp cutoff in the precipitation on this particular map. Okay. If we step forward in time just a couple clicks, you can sort of see that region as the cyclone keeps intensified. It's further and further to the east, but you can see this air that's descending. Again, if these isobars were fixed in time or fixed in location, we would actually see this would be diagnosing descent there. You put the relative motion of flow on an isotropic surface to diagnose the vertical motion. All right. One final look, and we're going to go back to the beginning of this. We're going to look at the dynamical tropopause, 2 PBU surface. Let's go back to 0 and just follow the progression of this upper trough as it heads across the mountains. And this is a very odd structure right here. So I'm going to ignore it. Melissa might see a dragon in this, or blue flames. Melissa, I don't know. Anyway, see the head right there. Okay, we step forward in time. Corpus right here. That's not encouraging.
Yeah.
We step forward in time. We can see this trough. You'll notice the minimum sea level pressure that's out ahead of this upper trough. And then, in my mind, this is when I looked at this earlier, looked like this cyclone, surface cyclone, we can keep moving forward, gets somewhat divorced from the location of this upper trough. This upper trough that I think triggered this initial cyclogenesis event, sticks back here in the southwestern United States. And this cyclone here, keep going forward, kind of gets out ahead of it. In fact, the flow gets so flat right here that you would imagine there's very little influence on this helping to amplify that thermal ridge over time. So this continues propagating toward the east. So we can keep going forward. Just look at the minimum sea level pressure on this map. There's certainly something lurking well to its northwest, but it's not really that engaged. But let's go a little bit further in time. Remember, this moves offshore. Second cyclone develops even further to the east. And then we get this next upper trough, this minimum in temperature on the dynamical tropopause, and finally begins to reach the east coast, and you begin to see an interaction with this intensifying really rapidly. This is a really low dynamical tropopause about to come right over the leftovers of that warm anomaly. And you got a really nice rapid cyclogenesis right there. So that's going to intensify rapidly. And there you go.
And like the confluence off the east coast relaxes by the time this one gets in place, and so it can kind of spin up because everything's just been getting stretched and shredded.
Right. So the complexion of the flow has changed with the arrival of that second upper trough, and that leads to a much more interesting event. Another trough has emerged in the westerlies and over the western part of the United States. We'll watch this again as we go forward into the time. As we get to the end of next week, we'll watch this cyclone that kind of just fades from it. This actually falls apart because it's this one that's going to be the more important one. This is 160. Watch this cyclone right here with a nice deep upper trough ahead of it. 1005, 100994. Look at this warming that's occurring along the diagonal troposphere. A lot of precipitation. We'll see on the forecast. And this wraps up quite nicely, very much like some of those early studies you were doing.
Yeah, it looks like that treble clef.
Shape.
We're right in the right spot for snow on Friday night. Next week.
Well. Let's look at the precipitation and moisture we get to this time. Excellent. You're not gonna like it, John. No. I don't think. It just dries up so much warm air in this. If we go back a couple clicks, you can see that warming the dynamical tropopause isn't just associated with warm advection here, it's really associated with late heating that's occurring ahead of the upper trough in this broad area of precipitation causes warming. So if you're from, the northern part of Wisconsin through, I guess, just south of Minneapolis through across through Oregon, all the way to Kansas City, that looks like it's cold enough, at least in this forecast, for snow, but broadly rain over much of the eastern part of the United States. Can we go forward with this?
The track and timing of this has changed so much over the last couple of days.
Yeah.
So
But, one thing that gets me nervous about prospects, even if this track were right, you're right about the warm air. Look at how much area there is raining to the northwest of the cyclone center at this time. It's a huge distance.
And look at the thickness of the these are, this is
Yeah,
540, well below.
usually, I guess if it's in early January instead of early December, it's cold on the northwest side of the storm. It's just not cold uniformly there yet. So it's going to be everywhere except Madison in Milwaukee.
Right, so maybe turning to snow when we get to next Friday evening. Let's just look at a couple of the runs. We can just go back to yesterday. Again, this is not searching for the run we like. That's a run that's probably.
I like that one. Yeah.
And really to do justice to this, we want to go through and try to understand what were the differences in the forecast earlier on that contribute to this difference. Is it just a slight change in the track? I don't know. It's very here.
It's a very different track, isn't it?
992. At the same time, it's moved just in.
I think the storm is a lot warmer. I think, like you said, I think
More intense.
that old run it's colder to the northwest everywhere. It's not so in the new one. Look at that. That's worse because it snows in places where it shouldn't when we don't get snow.
Right. Final thing I'd like to just point out, as we can look at the storm from a couple of perspectives. Once this goes by, we're going to see temperatures. We looked at this last week, looking well ahead of the forecast. Maybe we'll go to pivotal and look at the temperature anomalies over North America. This is the last part. It'll take us all the way to the next weather watch.
Yeah, January 25th.
Almost.
At which time we will have accumulated 80 inches of snow.
We'll see. CFS
8.
And let's look at the 2-meter temperature anomaly. Again, this one run, I'm not going to get too excited about it. It's at 12 hours, and we can just go through it in broad chunks. Let's go to 168 and go a weekend. 168. Oh, you can see this warm up, and this has been fairly consistent for the last several runs. This might be residual snow that's that's impacting surface temperatures over the Carolinas.
It's temperatures in southern Hudson Bay.
Yeah. Right. Even though they've been really cold there, it looks like things are going to flip. Again, we'll look at a lot of these. Let's go to 348 hours. Just the interest of time. Cold in the southeast. Go to 540. So again, this is really getting fiction land, but persistent.
Wow. 41 degrees in Winnipeg.
This is anomaly. These are anomalies. We want to just look at the actual air temperatures forecast by the model. Look at that. Wow. And that probably speaks to not much in the way of snow cover.
Yeah, right.
I think it's difficult this time of year to get temperatures like that. You don't have significant snow cover.
If there's no snow there, we have no chance in a winter like this.
And we'll go ahead.
We're not that warm.
I know, but we're
In
going
the
to be.
20s in last January.
Yeah, we'll go to the, actually, let's go back just for fun. We'll go to 444. Again, I don't believe this explicitly, but if you're curious about, 25th and what the weather could look like in this non-perspective, pretty boring pattern across the country. But obviously, this is fiction land. And we'll just go to the end of this.
It looks like an El Nino pattern again.
And here we are, I guess, to the 8th.
How about Phoenix? What's it?
Oh, yeah.
We're in Phoenix.
Yeah, right.
Phoenix is a little chillier probably than normal.
Phoenix was about right here, 48.
That's nice.
And that's at 0Z, so it's in the afternoon. But a broad southeast being warm, I think that is typical of El Nino type patterns. And finally, the last thing, when we get to the end of this pattern, go to the snow depth.
Oh,
That's what the country looks like. Again, still snowy over here.
what does gray mean?
So scroll up a little bit, scroll up a little bit. So it's 0.0.
What it is now.
That's right, it's just like that.
Right, yeah.
That's terrible.
And if you want to just get one left, I do this all day, but if we can scroll down again, just look at one other run. Let's just go back to yesterday. We don't have. We can't do it, right. So if we go to 720 hours, let's say, and then look at last few runs that support that.
Maybe we'll get it all in April again.
No, let's hope. Yeah.
No, that's different. That's one, but if you just look at consistently.
Bullseye over Rhinelander, of course. In every run.
Anyway.
Rats.
Well, thank you all for the semester coming to Weather Watch and participating. Hopefully we'll have more grad students and undergraduates that have gotten through 452. I think you're all ready to give map discussions. I've seen some of them working through. It'd be great to see you guys up here. But have a wonderful week of exams and nice holiday.
Yeah.
Thanks, John.
Thank you, Michael. Thank you, Pete.
Not getting when we're exams start at the end of next week, so you still have that.
UCMWF doesn't show anything on that.